Good morning, children. We come back to the chapter Polynomial. Last week we had done first exercise and you know now what is a polynomial. Let me recall 4x cube. One polynomial example I am taking for you. This is a polynomial, right? Of degree 3 because that is the highest exponent. We denote it by a small letter and x in bracket. Either px, qx or any other letter. So this is a polynomial of degree 3, right? So now let me replace x by 1. Okay, if I replace x by 1, I will be getting, in place of x I put 1 and here I will get 4 into, see children, 4 into, I can put it in the form of a dot here. Okay, not necessary that cross only we should put. So as we go in higher classes, we have to change some of the notation. 4, 1, 2 into 1 square, 3 into 1 plus 2. So what I get? And that is equal to 7. So what you see, when I replace x by 1, I get the value of px as 7. So what we say in such cases that the px at x is equal to 1 is 7. So px at x is equal to 1 is 7. Okay. So similarly we can take some another example. Let me take qx. Okay. Qx is equal to x plus 5. Simple linear equations, known as linear equation, the degree is 1, right? And here I'll replace x by minus 5. So if I replace x by minus 5, what I get? I get this as 0. Here I got 7. So here you say that qx at x is equal to minus 5 is 0. Okay. So children, now the difference what you see from both the example is, in one we get a constant number 7, whereas we get another one 0. The second one, okay, the second one what you see, when you substitute minus 5, the polynomial changes into 0. Therefore, this minus 5 is called zero 0 of the polynomial qx. Okay, so this is a new term for you, 0 of a polynomial, zero of a polynomial. It is that value which when replaced by x, the polynomial turned to 0, then we say that value as a 0 of a polynomial. So 0 of a polynomial px is a number c such that pc is equal to 0. Okay, so now let me take another example, and that example will take as rx. Okay, we'll change the name, and now I'll take a constant polynomial 5. We know 5 cannot become 0 because 5 can be written as 5 into x to the power 0, right? Whatever value you put on x, the answer will be always 5. It will never become 0, isn't it? Therefore, the constant polynomial has no zeros. Even if you substitute 0 here, 0 to the power 0 is not defined. It will never become 0. So, the polynomial will never become 0 here. Therefore, the constant polynomial has no zeros. So, a non-zero constant polynomial has no zeros. Okay, so another example let me take. Okay, gx, and this time I will take the polynomial as 0. You know that 0 is also a polynomial, and this is known as 0 polynomial, right? Now what will be the value of 0 here? What will be the zero of this? Okay, 0 can be written as x to the power any number, right? Whatever value you put on x, the answer will be always 0. Therefore, the 0 polynomial has all the real numbers. Okay, so these things you have to remember it because it will be useful for the MCQ questions. So remember here children, 0 of a polynomial is zero of a polynomial px is a number c such that pc is equal to 0. A non-zero constant polynomial has no zero. Every real number is a 0 of a polynomial. So this 0, ZERO has to be written as ZERO only. You will not write it in the form of a letter. Okay. Now let us check whether -1 is a ZERO of this polynomial. So we will take the polynomial. We will replace x by -1. And we substitute, since it is minus, we have to put bracket, remember, bracket, okay. Minus to the power even number is plus. So, -3 minus 2, you get -4. So, since p to the power p of -1 is not equal to 0, therefore, -1 is not the ZERO 0 of px. Had it been 0 here, then p of -1 would have become ZERO 0 of px. I hope you understood. So this was a new term for you today, that is ZERO of a polynomial. Okay. To find the ZERO of the polynomial, what we do? We substitute the value of x to that number and then find the ZERO. So ZERO can be 0. ZERO cannot be 0. So need not be 0. Okay. It is not necessary that it should be a constant. It can be 0 also sometimes. Here it is 0. Right. Here it is 7. Now, children, one thing you remember that whenever you take a polynomial, you should not equate it to 0. If you equate it to 0, it becomes an equation. That is known as polynomial equation. Polynomial is an expression. Okay. I hope this is a simple topic. You can do exercise number 2.2, okay, of the textbook. If you do not have the textbook, I'll send you the snap of it. Okay. Now, let me just, before we wind up with this topic, let me recall what you have done. A division of a polynomial in the 8th standard, and more about it I'll be telling you tomorrow. Division of a polynomial, 8th standard, just recalling. Okay, here I have taken a polynomial, this one, x to the power 4x plus 2x cube plus 4x minus 5, and I am dividing by x minus 2. Okay, so what we do? We first write the terms in such a way that the exponents are in the descending order or ascending order. Here I am taking descender 4, 3, 1, 0. This is the exponent, right? Similarly, here also exponent has to be kept in the descending order. Later, the first term of this and the first term of this we divide, right? And what you get is x cube. Then you will put x cube in the quotient, right? X cube into x is x to the power 4. X cube into minus 2 is minus 2x cube. Then we subtract, just like how we do subtraction in the usual division. When you subtract, the signs will change, right? And this will cancel. X to the power 4 minus this will cancel. And what you get? 2x cube plus 2x cube, 4x cube. And this you will get it down as you do in your usual division. Then again the first term 4x cube, you will divide it by x, and what you get is 4x square. So 4x square will be in the quotient. So 4x square into x is 4x cube. 4x square into minus 2 is minus 8x square. Then you subtract. The sign will change. This will cancel. Now what you see, you cannot subtract these two because they are unlike terms. This is x and this is x square. You cannot subtract. You have to keep it as it is. So plus 8x square, you keep it as it is. Then we write 4x. Then we write 5 because we want to write it in the descending order of the exponent. Now again the first term of this and first term of this will divide. We get 8x. So we get 8x square minus 16x. Again subtract. You get 20x here because plus minus 5. Till when you will do? Till the degree of this polynomial is lesser than the divisor. Here the degree of the divisor is 1. So we have to keep on doing till we get a constant number. That means degree has 0. So for 20x minus 5, again 20x divided by x, then we get 20 and we get like this sign change and we get 35. So what we see that here the quotient which I am denoting as qx is this, and remainder we'll take it as rx, and that is equal to 35. Okay, this I have done so that you will recall what you have done division of polynomials in the 8th standard. Now I have to be, tomorrow I am going to teach further on this. That time I will not teach you division. I will be teaching you something else. Okay, so children, division of polynomials, I will 1 or 2 problems I will be giving today for your homework so that it will be clear to you. Okay, so today what we have learnt? Today we have learnt what is 0 of a polynomial, what is the 0 of a constant polynomial, what is the 0 of a 0 polynomial, and also we recalled how to divide a polynomial by another polynomial, and this time I have taken a linear polynomial as a divisor. Okay, so by this today's class is over. Thank you and have a nice day.